Alrighty, my little friends, I hope you're all getting on well, and life is treating you well, etc. And you're getting on with your honours projects and your serious games coursework and everything like that. And today we're looking at the design principles of serious games. And I know you've seen this sort of format before in the coursework overview. So just to sort of put you back in the picture, that was for language education, medical education of course, leadership, managerial education, interpersonal skills, cancer research, or making people more sort of familiarised or more involved in their cancer treatment, military recruitment, mathematics, scientific inquiry, and Second Life. There have been many, many games in Second Life. Okay, so today we're looking at the principles of gameplay design. So that's the sort of general principles of gameplay design that I just sort of swiped off the internet from somewhere. I can't really remember where, which is terrible. What motivates people to play computer games? I have done many, many studies, sort of in 2005, 2007 and 2009. I did various sort of surveys at the university to look at what motivates people to actually play computer games. And then I combined them all into one, and I believe I had about 2,226 participants or something like that, and I called it a longitudinal trend analysis. And you can sort of read that paper if you want. I think it's called The Differences in Motivations in Online and Offline Game Players in Higher Education. I think it's something like that. Anyway, I published it in Computers in Education many, many moons ago, and you can have a look at it. But essentially, one of the biggest sort of things that motivates people to play computer games is challenge. And in order to increase prolonged participation, challenge is another one of those sort of key buzzwords as well. Now, when you're actually sort of performing research like that, you think, is it really necessary to perform research to find that out? Well, that's open for debate. Challenge is a bit of a buzzword, and it does seem like common sense, but I think it was challenge, curiosity, and competition that were like the top three sort of motivations or something like that. But anyway, I shall show you the results of that. What are the learning principles of good games? We're looking at the work of James Paul Gee, or G, who sort of came up with that. He wrote the What Video Games Have to Teach Us About Literacy and Learning, or Learning and Literacy book. And he's a big professor at MIT, and he's sort of seen as one of the sort of gurus of games-based learning. So he wrote that book, and he came up with 36 principles of good learning, good learning principles of good games. So 36 good learning principles. What favourable features should be present in a computer game? Do graphical user interface principles apply? Of course they sort of do, but we can discuss them as well. So that's kind of going into the realm of general computing, human-computer interaction, and then some potential guidelines for designing a serious game. So you've got in your coursework a small section on design, and you can put some of these things in there if you so desire. And what I was really sort of looking at was assessment integration, content integration, and also some UML diagrams, and you can put some of this in it as well if you so desire. So potential guidelines for designing a serious game, and some additional issues as well. So in terms of principles of game design in general, what you're trying to sort of do is build it around a sort of core game mechanic. Now, I have a lecture on game mechanics that I sort of do for the first years, and if you're looking at particular game mechanics in association with your honours project or dissertation, then I shall make that lecture available to you. Won't necessarily make the recording available to you because you'll be bored out of your mind listening to me. But anyway, I've got a sort of nice lecture on game mechanics where I talk about it quite in depth. So, a core game mechanic, that's what you're supposed to sort of build a game around. And in that particular lecture, I'm referring to a particular group of academics, and they define core game mechanics as a set of activities that are undertaken more frequently, indispensable to winning, and are most important as the player has to deal with them the most. So, I mean, when you think of something like Mario, the jumping, the obstacles, that sort of thing. And then, of course, you've got things like Angry Birds as well. Easy to learn, sort of fun to master as well. So you know the sort of mechanics in Angry Birds where you sort of stretch them back and whew, and let them fly, sort of thing. You got other sort of game mechanics as well. You get satellite game mechanics, enhancement mechanics, alternative mechanics, opposition mechanics as well. And then, of course, you've got a whole load of different sort of classifications of mechanics as well, and that's in that lecture. So you have things like physics, economy, progression, tactical manoeuvring, and social interaction. So these should be easy to learn, fun to master. There should be rewards, hidden levels, cutscenes, that sort of thing. These principles can be thought of in level, in a sort of system-wide sort of variety, UI, and the story, so they should be incorporated into these things. There is a sort of direction that has to be followed as well, so there's a focal point. You're never really allowing the player to guess what they should particularly focus on, so there should be some degree of anticipation. You should announce change, and there's a picture of Granny that my nephew was obsessed with at one point. And really what you're sort of doing there is you're running from this maniacal granny that's trying to, a zombie granny that's trying to kill you, and it was in Unity 5 that was implemented. And then of course you sort of announce change as well. So within that game you have a, I can hear you, this little old granny sort of coming towards you. Behaviour, these events have to be believable events and behaviour. So there's Sharon Stone there from Basic Instinct, suspension of disbelief. You make things up, make stuff up, it has to be believable. It's called suspension of disbelief. And overlapping events and behaviour has to be the correct amount. Now I have these here in particular because if you actually watched these, for a start, Catherine Tremell in the Basic Instinct movies, there's two, and she is more or less completely and utterly clairvoyant. She's a brilliant psychologist, we're led to believe, but that doesn't necessarily mean that she can predict human behaviour to a T. He is exactly the same, and at some stage, after 3 seasons, you kind of have to think to yourself, wait a minute, all these murders are happening around about you. So, I mean, it's not necessarily believable, but it unfolds. And there's Jessica Fletcher. I could have told you absolutely everything about Jessica Fletcher one summer, because I watched all of Murder, She Wrote. But, of course, it always seems that all the murders are happening round about this woman. And it would have been absolutely brilliant at the end if she just said, I did it. That would have been the brilliant ending episode. Game of Thrones, we all followed Daenerys and Drogon, and she was really quite a good character up until probably the last 3 episodes or something like that. Then they switched it and they made her kill everyone. And was that believable? Not entirely certain it was. So overlapping events and behaviour has to be the correct amount, okay? Other principles, physics, there has to be space for characters, particle effects, when the cars are scraped, perhaps. Physical metaphors, characteristics of inventory items, sounds, when flies get close to the camera, for example. Progression, there has to be a bit of pacing, a sense of urgency, perhaps vast spaces, narrow ones in terms of the environment. So a sense of urgency, I always sort of think of that sort of cat and mouse level in Doom, Doom 64, where you're actually sort of, which was a long time ago, it's called Cat and Mouse, and you're running from the cyber demon, which was the hardest sort of demon in the game at that particular point. Environment, spacing, there has to be sort of spatial placing, indexicality, that sort of thing of elements. It has to be realistic. The method, there's a sort of linear design, or all solutions are important, or is there a component sort of breakdown? So what sort of happens from pieces of the story, or pieces or goals within the game? Is that a sort of linear sort of way, or is it compartmentalized in a sort of component breakdown where some form of prioritization has to occur? So you have to think about the method as well. So the foundation, the player, the communication, and of course the appeal. Now these are some 13 principles of gameplay design, or you can look them up. And I do believe there's a very sort of large book on level design as well that sort of breaks these components down. However, we're really looking at, that was just a sort of brief overview. I've got a lecture on game mechanics. I can make that available to you. And this is really talking about what motivates people to play computer games. So based on a very wide review of the literature, this particular academic here, Allers and al. in 2002, identifies 6 dimensions or characteristics that can, in fact, describe any game. And these are 6 motivations for playing computer games and must be acknowledged when really designing games for student-centered learning. And these 6 dimensions are, in fact, fantasy, rules, goals, sensory stimuli, challenge, mystery, and control. Now, these are not completely and utterly dissimilar to Malone and Lepper's framework of intrinsic motivation. So fantasy, it's almost as if you're assuming some sort of role, perhaps in terms of student-centered learning, or games-based learning, or serious games. There has to be some form of rule enforcement, goals within the game in order for you to set the scene. Some form of sensory stimuli, whether that's visual, auditory, perhaps even physical nowadays. And there has to be some form of challenge and something to maintain your interest, pique your curiosity. There has to be some form of mystery, and then of course there has to be some form of production and control that you're asserting some control over the game and asserting some control over the outcome. Okay, excellent. So, fantasy games are staged in a virtual game world and have absolutely no consequences in the real world beyond the limits of the game. Now, that is not entirely true because, I mean, even if you play a game, your heart rate sort of, fluctuates, that sort of thing. I remember when I got my Game Boy for the very, very first time back in the early 80s, late 80s perhaps, early 90s. And I played it for 6 hours, and I remember getting heart palpitations. So that was definitely a real world consequence brought on by too much playing. And it depends what sort of game it is. It can be exogenous, endogenous, or perhaps a cunning sort of mixture of the two. Now, in terms of endogenous games, this is really where everything is related to the learning content. So, for example, a game that allows the player to learn about forensic detection while catching a murderer in the game environment, perhaps. And then you have exogenous, where what sort of happens is the learning content is more or less detached from the game. Now, I remember one particular stage in the Atari ST, I had this particular quiz game, and if you answered the quiz correctly, or a number of questions correctly, you were allowed to play this little sort of mini game where you saved a princess from a dragon. And that had absolutely nothing to do with the learning content at all. It was merely sort of little reward, so that's sort of exogenous. Okay? And then we have rules, goals. A game must possess a set of precise rules in order to govern it. There's going to be boundaries, constraints, while at the same time making it possible to actually achieve these things. Now, the first years always sort of slay me a little bit because there's always a good 3 or 4 of them that will design a game in first year in Game Maker or whatever for their introduction to games development course, and they'll always make it far too hard, even for them to complete. And you can always, it always seems to be, I don't know why, with a sort of perhaps German, Austrian accent, and they're narrating all the way through this, and they say, I cannot complete my game. And then they swear, and it's really quite amusing. But anyway, they haven't quite got the balance correct there in terms of the rules and the goals and the challenges. Now, you have things like system rules, so let's have a look and see what that is. That really defines the operation of the world embodied by the game. You have things like procedural rules, so that defines actions that can be taken in the game. So, for example, in Zelda, you might want to collect the 20 secret seashells, then you acquire a second Master Sword or something like that. Imported rules that the participants of the game import from the real world so that play can in fact sort of take place. So think about that. Sensory stimuli. Appropriate sensory stimuli are achieved in computer games through the use of 3D graphics, sound effects, and now, of course, physical stimuli relatively easily. And I always sort of remember the first time I had a sort of rumble pack experience in the N64 back in the day when it was just sort of starting to become a new thing, and we had this rumble pack with batteries in it, and I remember us crashing into a mountain in Star Fox 64 and actually dropping the Nintendo 64 controller. But of course, nowadays you don't know you're born, because absolutely all of this is incorporated into the controller. You don't need to wait until the batteries run out, then run down to Woolworths, I know, Woolworths in order to get batteries and things like that. That's what we had to do back in the day. Okay, so challenge, Malone and Lepper in 1987, this is the framework of intrinsic motivation, state that individuals require an optimum level of challenge. And achieving that can be incredibly difficult for optimum immersion. And you have clear goals, you have a progressive difficulty levels as well. You can track the progress through the feedback, and there's meaningful goals as well. So, mystery, this is sort of related to curiosity, and it's one of the primary factors that drives learning. And there's two different sort of kinds. So there's the sensory, and that's achieved through the sensory stimuli, the graphics, the sound, the appropriate feedback, that sort of thing. And cognitive curiosity, so you're really looking at a sort of desire for knowledge there. So you're trying to incorporate all of these things into your sort of serious game as well. Control, the ability that the participant has to make changes to affect the game world in some way, and that's quite evident in good games. So I can think of Star Wars Knights of the Old Republic, for example. You can go quite clearly to the dark side by killing little creatures, etc. And you can see that the change that actually makes in the game world to you. Malone and Lepper, 1987, they present a framework of intrinsic motivation. Now, when I did all this sort of research back in the day when I was sort of doing my PhD and my MSc in computer games, I did look at all of this, and I used Malone and Lepper's framework of intrinsic motivation and split it into the individual factors, because if you're doing something like this for your honours, you have to actually look at some sort of theoretical framework that's already in existence, that's already been validated, that is already within the literature and has been validated in terms of research and credence and academic rigour. So this one I used, and I had the individual factors and the interpersonal factors. So challenge means the player must be able to vary the difficulty. Fantasy, they should feel immersed, connected with the characters. Curiosity, there should be some sort of sensory stimulation to ensure prolonged participation. And then of course the control, where the player has the ability to sort of make choices. Interpersonal factors and things like that, cooperation. So these, of course, the previous ones were the individual factors, but these are interpersonal, where you're sort of working with other people. So cooperation, the player should experience satisfaction in the process of assisting others, perhaps. Competition, the player should be able to compare their performance to others. Recognition, they get satisfaction from being recognised for that sort of thing. Now, it really does depend on what particular kind of player you are. You could be a cooperative game player, you could be a competitive game player, you could be a cooperative player in a sort of competitive group dynamic, perhaps. You could be an individualistic game player. So that might be something to possibly consider. So I did mirror studies, study 1 in 2005, study 2 in 2007, and study 3 in 2009. And what sort of happened was challenge was considered a bit of a buzzword, so it was the most important motivation overall. Cooperation and curiosity were quite up there as well. Competition was relatively slightly important, but then of course I got the psychologist involved, and what sort of happened there was we started adding things in like pleasure, relaxation, and that sort of muddied the waters a wee bit. But anyway, those were some studies that I did back in the day to show you exactly how people or why people play video games. So you can see that in study 1, leisure was also quite important as well. And then what sort of happened was it started to sort of fall away. And then pleasure, relaxation, they became a little bit more important. And I think that's probably because people maybe can't differentiate between pleasure, relaxation, and perhaps leisure as well. Okay, so that's just for your, sort of benefit there. So James Paul G, he's written a number of papers and defines a number of, 36 learning principles of good games. And in one of these papers, I sort of have them referenced at the back. If you're looking at these learning principles of good games at all, then probably reference this. And they do apply to sort of games for entertainment as well. So the most important sort of 16, I believe, are identity, and this is how a good game captures and immerses the player in order to enhance the situated learning, particularly for a serious game. So it captures and immerses the player, particularly when you're talking about learning a new domain of knowledge, and requires the player to fully embrace a new identity, new responsibilities, a new role. And this can be done in two ways. You can either assume an identity, or you can create an identity. Now the jury is still out, and I believe that there's still quite a bit of scope for research in terms of looking at what a player actually feels more emotionally connected to. Now, do they feel more emotionally connected to a character where they assume the identity, they're just basically given a powerful character, it has to be an appealing character, or do they feel more emotionally connected to a character that they in fact create? And it's interesting to possibly look at that sort of thing. I would say that's worth an entire honours project on its own. I remember, particularly in Destiny, the first time I played Destiny, I spent about 45 minutes picking the look of my character. So these are some of the characters, the powerful characters that you get to pick in games. Darth Vader's apprentice, Link from the Zelda games, Mario of course, Bowser, the Joker, Magneto from the X-Men, Superman, Injustice, that sort of thing. So yes, the jury's still sort of out on that. More principles, interaction. This is the essence of a game. It provides the feedback and provides new problems in reaction to the player's actions and decisions. Production, in the most sort of basic sense, the players are in fact producers in the virtual worlds that they live in, and they have the ability to write the game and produce the game, and this possibly increases the prolonged participation as well. So that's something to think about. Risk taking, it's a sort of good sort of idea of a game mechanic as well. So good video games decrease the consequences of failure. Players experience either a minimal of real world consequences or indeed no consequences at all. So what sort of happens is you get the chance to replay things over and over again until you sort of get it right. And that's absolutely fine. I mean, you just respawn and there you are. Back in the day, in the Game Boy, for example, you didn't always necessarily have that. You had the idea of the game mechanic permadeath, perhaps, and you just get put back to the beginning of the game and that was you, because games were shorter. Yeah. But nowadays, it would be inhumane to if you took 160 hours to complete a game, which is pretty much the norm nowadays, I would say, and they just put you straight back to the beginning and said, don't switch off the machine. That would be inhumane. Customization. The players had the ability to customize the game to the particular attributes. This can be in terms of character customization, perhaps, or difficulty level. In my day, it was a case of easy, medium, hard. And now we have very, very easy, we have very easy, we have easy, we have a whole load, an entire range, a spectrum of difficulty levels in order to increase that customization. Agency, this means that a player has a sense of ownership over what they are actually in fact doing, and this is achieved through the various principles that we've discussed before, so identity, interaction, production, risk, and customization. Well-ordered problems as well. Good games produce well-ordered problems that allow the learners to draw on previous experience to solve sort of future problems, and that's sort of linked to challenge and consolidation. So they're using the previous experience, and that can appropriately be assimilated and utilised later on in order to solve another newer problem that's a slight permutation. So it's kind of the basis of all constructivist learning. Challenge and consolidation, they allow the players to solve challenging problems in a way that they have sufficient practice, so that solving the problem just becomes sort of second nature. So for example, I was playing Super Mario 64 the other day on the Switch, and what sort of happens is the first sort of big bad guy, the big bomb, you run up behind him, you grab him, then you sort of fling him, and he's damaged, and that's fair enough. The next one is a sort of block that does this, so you've got to evade him and then sort of jump on him in order to do that. Then of course when you get to King Bowser, you've got to run behind him, and it's a combination of all these things. You've got to evade the fire attacks, you've got to run behind him, grab his tail and go, "Songy Bowser!" Or whatever. And that's the sort of basis of challenge and consolidation. So you're sort of pushing the player's slight limits as well, and it's the basis of sort of constructivism. Just in time or on demand. So good games give just in time verbal information or on demand information when the player requires it. Zelda games are incredibly good at that sort of thing. For example, there's a little sort of fairy in one of the Zelda games that goes "Zzzz," and it draws your attention to things when you need it, when you're there. There's no point in giving it to you later, so it's on demand and it's sort of just in time. Situated meaning, research shows that only when words can be attached to experiences, so actions, images and dialogues that they refer to, can their meaning be properly sort of learned. Has to be sort of pleasantly frustrating. So this is Bethesda 2000. Due to a combination of all of these things, has to be a little bit frustrating, but certainly not too hard. Otherwise, the player sort of starts to lose interest. So, according to this particular academic, it has to be within their regime of competence. Systems thinking. Good games encourage players to think about the effect of their decisions in the game world as a whole. And I can only think of one example here off the top of my head, and one of them is sort of Zelda Link's Awakening on the Game Boy. You have the ability to actually go in. You can either save like hell in the original Game Boy version and get 999 rupees in order to afford this bow and arrow. Or you can in fact just run round about, disorient the shopkeeper and run out the store and steal it. And if you actually do that, then your name gets done away with in the entire game forevermore, and you're just referred to as thief. So you've got to think of it system thinking. So exploration, lateral thinking, rethinking of goals, and games encourage a different attitude from moving too fast, and also encourage lateral instead of sort of linear thinking. We also have smart tools and distributed knowledge in games. So a good example of that is perhaps a game called Full Spectrum Warrior, where you have a number of sort of team members that sort of either assist you or have different expertise. So the virtual characters sort of help you there as well. Cross-functional teams, people sort of specialise but integrate and share, or their sort of common goals, organised around a sort of primary affiliation, and use their cultural and social differences as strategic resources and not necessarily as barriers. So performance before competence. Apparently good video games operate by a principle just the reverse of most schools. So performance before competence. So I really don't understand what that means, to be perfectly honest. It sounds like hogwash to me, but you don't necessarily just have competence and then performance. I don't really think that's the way schools work, but I'm not really entirely certain what the academics sort of meant, what he meant by that. So you're allowed to disagree with these things nowadays because you are an academic yourself. So what favourable features should be present in a computer game? The game world, there should be an illusion of free will. Should be provided in a game by the employment of an intricate web of cause and effect. Regardless of everything, it is all still sort of programmed, and it doesn't necessarily take on a life of its own, so to speak. It is all pre-written, it is all pre-programmed, and it's just by sort of the joy of object-oriented programming, where you're letting all of these objects interact with each other, and hopefully the result will be an okay one. So this means a game cannot simply move linearly like a story or a movie does, so the player should have as much freedom as possible within the confines and the constraints. So you have a sort of different number of scenarios that the players can sort of move to there. You have synthetic players as well, and these are the sort of computer controlled characters. And even back in 2003, Smed et al. Identified the following sort of major features. You probably refer to these as NPCs nowadays, AI, that sort of thing. And synthetic characters should have real-time response, distribution, autonomy, and communication as well. There should be the idea of multiplaying, so complex interaction between human players, synthetic players as well, in order to get more of a sort of storyline and more prolonged participation. If that doesn't sort of happen, then the novelty soon wears off. Extensions as well, we've all sort of seen them, so ways of providing extensions to the gameplay. Replaying in this particular context is that it means that the game should be, it doesn't necessarily mean that the game should be replayed, but it means that the players can in fact look at the highlights of their own particular gaming experience. So this is probably attempting to mimic real life, as in real life people just taking photographs and video recording their sort of joyful experience. So in the Switch you can simply take what you call it, snapshots of your screen, or if you're sort of playing a sports game, I remember back in the day what sort of happened was if someone scored a goal, they were able to watch it, they were in control of the countless replays, and you were sitting there sort of bashing your controller, hoping for some bizarre reason, by some miracle, that it would skip it, even though you had no control over it. And it's only when they were satisfied were they able to sort of go past the recording. And it showed you all from different sort of angles. Do graphical user interface principles apply? Of course they do. Has to be a sort of user-centered design. There has to be directness of manipulation. Countless metaphors are sort of used in games as well. Consistency is another thing. If you go from one display to another, it has to be consistent in order for the player to sort of follow it. Appropriate feedback, of course. Aesthetics, forgiveness. Do you want to delete this file? That sort of thing. Are you sure? Simplicity. And you've got to think about human memory limitations as well. So a human can remember things in chunks, essentially. So 7 plus or minus 2. And system messages as well. Back in the day when C++ was introduced in its infancy, you would get error 3.14159 has occurred, and you're going, I don't know what that means. So, I mean, these things have to be interpretable, shall we say. So potential guidelines for designing a serious game, focus on the pedagogical underpinnings. So in your coursework, you're looking at the 3 to 5 learning outcomes. So you select a topic that you know, address and define the learning outcomes. These are very, very concise statements. I think I've sort of spoken about these things before, where my learning outcomes for my serious game for my PhD was looking at system requirements, well, not system requirements, it was requirements collection and analysis at tertiary education level in software engineering. So essentially I was looking at attempting to help the user learn the difference between systems requirements, user requirements and domain requirements. So that was 3 little sort of requirements and conflictions as well. So 4 very, very small, concise requirements. Doesn't have to cover an entire subject area. There's no point in saying we're going to cover an entire sort of first year math course. That's just not going to happen. And how are you going to assess that learning has in fact occurred? So assessment integration has to be sort of contemplated there. Is it going to be scoring during gameplay? Is it going to be a multiple choice test? We'll cover assessment integration in a future lecture. And how are you going to evaluate your serious game? How are you going to actually evaluate this learning has occurred, and that's going to be effective? So we'll talk about that in a future evaluation lecture. You do not want to miss the evaluation lecture, because the evaluation lecture will give you away about 20 marks if you just listen to what I'm saying. Okay, so begin with an initial problem, grounded in professional practice. Has to be realistic and complex enough to develop analytical and problem-solving skills, perhaps. The learner has to take responsibility for their own learning and be aware of the knowledge construction process. So that has to be taken into account. Metacognitive strategy formation allows the learner to identify his or her own process to reach a solution. So it has to be exploratory, it has to be customizable for particular learning types, that sort of thing. Provide learners with the opportunity to experience and appreciate other perspectives. Now this is all easier said than done. This is all highly sort of theoretical, but back in the day, this was a bunch of design guidelines for serious games. So there you go. Provide opportunities for interaction and collaboration. Either that's going to be learner to learner, learner to teacher, learner to system, that sort of thing. Ensure that the learning environment motivates, engages, and challenges the learner. It's amazingly large. Can you in fact ensure that? All you can do is take all of your principles that you sort of know about designing good games and hope and pray that it in fact does all of these things. Provide feedback mechanisms in order to enable learners to be fully aware of their progress. So provide sort of scaffolding mechanism as well. So they should receive sort of instantaneous feedback. Or maybe not instantaneous, but certainly feedback that is timely in order to help them through the process. Scaffolding mechanisms as well, and it should ensure some form of flexibility to support different learning styles. That's what Mario Soflano actually sort of did his entire PhD on. He was looking at pictorial or picture sort of learning styles as opposed to textual. If you sort of look at one of the sort of previous lectures, that's one of the things where future sort of newer generations prefer sort of pictorial or sort of pictures, and they're subjected to diagrams, media, they don't read as much, that sort of thing, and maybe that's something to be brought into account. Provide opportunities for reflection, self-evaluation, articulation and debriefing. Reflection is a highly intricate and worthwhile process. So if you're sort of lacking knowledge or whatever and you learn something, then it's important that you go away and actually reflect on what you've learned and take some time in order to process it. And whether this happens in a cognitive level, in the sort of emotional level, or the psycho sort of motor level, it's all good and it's all beneficial. So the cognitive domain, the sort of emotional domain, the domains in what do you call it? The framework. What framework is it? I've forgotten the framework. It's in the first lecture in learning theories and models. I'll actually just look it up and make sure that I'm giving you the correct information. Let's just see. Just check. It was in the learning theories and models lecture, which so I can tell. Oh yes, Bloom's taxonomy. So whether that's going to happen on a sort of cognitive, affective, yes, cognitive and affective domain. So the sort of knowledge domain, affective domain as well. So that's emotional, the psychomotor domain. So that's really Bloom's taxonomy that I sort of latched onto there. Okay, so also to provide an integrated assessment as well. So we'll talk about assessment integration at a later date. Additional issues from a computer games programmer point of view. The vendors prefer to see on-screen results, and a very, very good programmer a long time ago on this course, it was actually the Computer Games Technology course, called Derek, actually pointed this out to me, and he said the most complicated programming is likely to get the least amount of thanks, and that's absolutely right, because it's probably entirely invisible, or it's doing a complicated thing while on the screen looking deeply unimpressive. So, gender inclusive, avatar selection, try and be as inclusive as possible in terms of diversity. There's a whole load of sort of things now, not just gender, but racial, sexual representation, gender representation. So do sort of think of that as well. Right, okay, I shall make that available to you. Sorry that I got a bit mixed up at the end. But if you get any questions, then just give me an email or we'll have a meeting, okay? Bye.